Okay, so we're going to continue on the lesson. And now it's asking, now that we constructed all these, the equilateral triangle, the perpendicular bisector, and the isosceles triangle. Now that you've constructed all these, right? And the isosceles triangle was kind of fun because we played with it, right? We went like this, like, ooh, yay. And it stayed congruent, right? So the question now they're asking is, can you construct an isosceles triangle, and AB is your base, whose vertex would not lie on the perpendicular bisector of AB? And we kind of talked about this yesterday. Why or why not? So could you construct an isosceles triangle whose vertex doesn't lie on the perpendicular bisector? You mean you want me to take a point over here? Okay, so let's take a point over here. I'm going to leave this guy here. I'm going to take a point right here, and I'm going to change his color to something like maybe green, orange, blue, gray. And then I'm going to make a segment from A to that point and from that point to there. And I'm going to make these gray so they stand out for you. Okay. You don't need to draw with me right now. You're just looking. This is you're not constructing right now. So right here, do you think this is an isosceles triangle? Two congruent sides? Does this look like an isosceles triangle? You guys are like, no, doesn't even. Okay, what if I did like that? Doesn't that look better? You guys are like, that's still not congruent, Miss Johnson. Okay, what about this side? Does that look better? What about down here? Can I construct an isosceles triangle with the vertex not being on this perpendicular bisector? Not here. So these are all isosceles. That's what we figured out in the last one, right? This one, can I get an isosceles triangle anywhere as long as it's not on the bisector? That looks pretty good, right? And you guys are like, it's not us. It doesn't look like it, Miss Johnson. And I can actually prove that this is not an isosceles triangle by using my compass tool, right? And I could say, oh, look, that's one. Oops, this is one. Oops, sorry. This is one length here, right? I can't do that. I need to undo that. Sorry. Because I want to move it. See how this is the radius? AD is the radius. Well, I can prove that this is not the same. Okay, look very carefully. Oh, where did my other triangle go? I lost it. I lost my triangle because I erased it, didn't I? I did. Dang. Here, let me build it really quick. Okay. Found his tool. Okay. So I'm going to go with this radius here. See how this is a circle? Now I'm not going to change the radius, and I'm going to go over to B. That's not the same radius. So therefore, A, whatever you are, AE is not congruent to EB. So no matter what happens, however I move this thing, these are not going to be congruent because it's not on the perpendicular bisector. Does that make sense? Once I put him on the perpendicular bisector, then he starts looking congruent, right? Those two segments look congruent. But if I pull him off the perpendicular bisector, does everybody see how he's no longer congruent? Very good. Okay, so how does this work relate to the perpendicular bisector theorem that we just proved? We talked about that already as well. All right, so let's talk about a couple words here. So it says, sorry, I just need to grab something. So it says, in the previous task, we proved the statement. If a point is on the perpendicular bisector of a line segment, it is equidistant from the endpoints of the segment. Everyone's like, yeah. So we use this theorem in the jumpstart when we prove these things. We constructed what? By selecting the third vertex of the triangle to be a point on the perpendicular bisector of AB. Does that make sense? We use this theorem in the jumpstart when we constructed, what did we construct? What was this called? What did we construct over here? Sorry, not this guy. This guy here. What was this called? What is that thing called? Yes, very good. An isosceles triangle. So can you write in here an isosceles triangle? Why am I not typing? There you go. Isosceles triangle. Very good. Isosceles triangle. Okay. Next one. It says statements of the form, if statement P is true, think if it rains tomorrow, it's true. Then statement Q is true, then Miss Johnson's going to bring an umbrella, are called conditional statements. You've heard of these for a really long time. Hey, mom, can I go to the movies? Sure. If, and then whatever the case is, right? So Cinderella is a classic conditional statement, right? Sure, you can go to the ball as long as you get the whole house cleaned, right? Something like that. So conditional statement is if, then. Converse, not like the shoe, the converse. Okay. In my brain, you need to remember this. Converse, everyone say switch, say switch. Like in your brain, can you please imagine you wearing your Converse shoes on the wrong foot? And I'd say, dude, you need to switch your Converse. Okay, switch. So converse is the converse of a conditional statement is of the form, and I'm going to type this out for you. If Q, I'll do lowercase q, then P. Do you see how I switched P and Q? So conditional statement, this guy says, if P, then Q. The converse of that statement is if Q, then P. Just because I tell you a converse statement doesn't necessarily mean it's true. For example, like let's just say, Mom, can I go to the movies? And your mom's like, sure, you can go to the movies. As long as you, and then I don't know, make sure that all of your math homework is finished. So then I see you and you're at the movies. I'm like, oh, that must mean that you did your homework, right? It must mean that you did your homework. That's a true statement. But just because that's so that statement. So if you do your homework, then you get to go to the movies. If you went to the movies, then that means you did your homework. Some of those statements may not necessarily be true. For example, if it's raining, then Miss Johnson's going to, I don't know, wear rain boots. If it's raining, then Miss Johnson is going to wear her rain boots. Okay. Let's see if that's true the other way. If Miss Johnson is wearing her rain boots, then it must be raining. Does that have to be true? Can you think of a case where Miss Johnson would be wearing rain boots, but it is not raining? Can you guys all think? Yeah, style, Miss Johnson. Exactly. Or maybe she's trying rain boots on at the store and you saw her, right? And you're like, it's not raining outside, Miss Johnson. Why are you wearing? So do you see how sometimes these are not going to be true? So just because I tell you to write a converse of a conditional statement, it does not mean it's necessarily true. All right, let's continue. Write the converse of the theorem we just proved about the points on the perpendicular bisector. So again, you're switching the arguments. So if it's raining, then Miss Johnson's bringing an umbrella. When we switch it, it looks like this. If Miss Johnson has an umbrella, then it must be raining. So we're going to switch the places. So if a point is equidistant from the endpoints of the segment, then it is on the perpendicular bisector of the segment. So we use the theorem in the jumpstart when we constructed, oh, we said this again, the isosceles. Okay. All right, let's move on. So it says select and sequence statements for a proof using flow diagrams. So a flow diagram means first this, then this, then this. It's just, it's a helper in order for you to start writing proofs completely on your own, right? So for example, do you remember when you first started writing essays? Maybe your teacher had you write a flow chart. Maybe your teacher had you do that web, like the bubbles, like here's the main idea, here's the first argument, here's the second argument, and then here's a detail off that argument. Yeah, there's different tools that your teacher did to help you be a better writer today, right? Maybe you did an outline, whatever the case might be. So this is going to be a helper for you to write your proofs. So we're going to be able to define lines and line segments that relate to all of these words: medians, altitudes, angle bisectors, perpendicular bisectors of the sides. So all of these words you're going to know, but right now you're like, I mean, I think this word sounds familiar, right? So don't worry about these words right now. We'll go over them as you all get there. Okay. It says, when a lot of things are true about a diagram, how can we identify and organize the statements that must be used to justify a particular claim? And besides the line segments that form the sides, what other lines and line segments are useful in describing features of the triangle? So we're going to go through this and make sure that you all are comfortable with all of this. It says, in the previous task, you were asked to justify some claims by writing paragraphs explaining how various figures were constructed and how those constructions convinced you that the claims were true. Perhaps you found it difficult to say everything you felt you just knew. Sometimes we all find it difficult to explain our ideas and to get those ideas out of our heads and onto the paper. Organizing ideas and breaking down complex relationships down into smaller chunks can make the task of proving a claim more manageable. One way is to use a flow diagram. So here you're going to tell me which one doesn't belong. In reality, all of them don't belong. It's just kind of like which one, how do you want to describe it? So looking at these A, B, C, and D, take a second. I'm going to pause the video really quick. And I want you to decide which one looks different than everybody else. And then just kind of argue. Everybody's going to be right. Okay. Just look at these diagrams, put on your super amazing observation skills between all of these, and decide which one makes the most sense. Okay. So some of you said, hey, Ms. Johnson, A looks different because it has this guy right here. He's called an altitude. Everyone say the word altitude, altitude. You've probably heard this word altitude if you've watched any movies with the pilot, or if you remember being on a plane and they say things like, yes, we're flying at an altitude of blah, blah, blah. So altitude literally means, this is the way my little brain describes it. I think it's just kind of a funny picture. Can you pretend that you were in a triangle building? Everybody pretend they're in a triangle. Yeah. And you're at the very tippy top. Good. And you drop down a rope. That rope is your altitude. I don't know why you're dropping a rope. That's just the way my brain works. Okay. So the altitude is literally perpendicular to the base. So whenever you went to the nurse's office, not nurse's office, whenever you went to the doctor to get measured or whatever, they always say, stand up straight. What you should really say is stand perpendicular to the floor. But, I'm trying to get that changed. People don't listen to Miss Johnson. So there you go. So it's just, it's from the top of your head perpendicular to the floor. That's how they measure you. Imagine if you were leaning kind of like sideways against the wall, she'd say stand up straight, right? Okay, some of you said this one. This is called an angle bisector. Everyone say angle, angle. Say bisector, bisector. If you remember earlier, we said that a bisector always makes two congruent parts. Earlier, it made two congruent segments like this, right? Boom, boom. But this is actually an angle bisector. So this line XB is actually bisecting, meaning cutting angle ABC into two congruent parts. Notice how you have a little arc mark there with a little tick mark. So that's one way to show that these two angles, angle ABX is congruent to angle XBC. This one here is called a median of a triangle. Everyone say median. Median. So median is from vertex to midpoint. From vertex to midpoint. Vertex to midpoint. Lastly, is a perpendicular bisector of a side, right? We already know what a perpendicular bisector is. Now, if you attach a triangle to it, then you're just perpendicularly bisecting one of the sides of a triangle. Okay. All righty. Each of these are very important. I will be going over these names again and again so that they're in your head and not just on our screen. Okay, so this is what a compass looks like. This is old school. I don't know. Have you guys ever seen these? Yes? Did you guys try to poke people and hurt people with these? Say no. No, we did not. Yes, I would always, when I pull these out of my classroom, I would be like, repeat after me. I will not use compasses. And then you would all say, I will not use my compass as a tool to hurt. As a tool to hurt. I will not use math tools. I will not use math tools to hurt my people that are around me. I don't know why they make them so sharp. They don't necessarily need to. But the reason why they make them sharp is so they stay where you've put it, which is funny because the desks at school always had these guys sliding around. So that was interesting. Okay. So Travis uses a compass and straight edge to construct an equilateral triangle. We did too, except for we used Desmos using technology tools as opposed to using, physical tools. He then folded his diagram across the points of intersection of two circles to construct a line of reflection. So he's basically doing this thing just so that you're remembering. Let me erase some stuff because we don't need this. This is me being extra. Okay. So he folds it across this line, right? And then he says, hey, look, it's a line of reflection. Do you guys all see how everything's being reflected? The left side looks exactly like the right side. Sometimes we call this a line of symmetry as well. I don't know where we are. We're here? No, we're like over here. So then Travis, Tahani, Carlos, and Clarita are trying to decide what to name the line segment from C to D. You guys already know the name of the line, right? Travis thinks that the line segment they've constructed should be called the median of a triangle. So I'm going to write some definitions down. I am going to write it here, and then I'm going to write it, where is my writing? Right here. I'm going to write more stuff up here. So I'm going to split my screen so you guys can all see at the same time. So median of a triangle is from midpoint to vertex. Okay. An angle bisector is a segment or line that cuts an angle into two congruent angles. Okay, an altitude. Oops. Are you not going to type for me? There it goes. Altitude is the height of a triangle, or it is from vertex to opposite side vertex, or it is from vertex to opposite side intersecting at a right angle. Okay, last one. Perpendicular bisector. We already defined this, but we will put it on our list of things. Perpendicular bisector. I'll fix that in a second. So, of a segment intersects the segment at its midpoint, forming right angles. Okay, there's your list. You guys have access to this. So I'm just going to take this off for, oops, I didn't want to take it off. Are you going to go for a second? No. There you go. I just want to show this. So Travis thinks that it's a median. So is this the median? Is it from vertex to midpoint? Is that true? Is it from vertex to midpoint? You guys say, yeah, Miss Johnson. Tahani thinks that it's the angle bisector. Do you remember how we proved this? We proved that these two were, this was congruent to this by proving these two triangles were congruent. So this is congruent to this, right? Okay. Clarita thinks it's an altitude, which this is perpendicular to it. So that's an altitude. And then Carlos thinks it's a perpendicular bisector. And if you remember, this was congruent to this. So the answer is yes. All of you are right. Okay. Okay. It shows the four friends are trying to convince each other that they are right. So a flow diagram shows the statement that can be written to describe relationships in a diagram or conclusions that can be made by connecting multiple ideas. You will use the flow diagram to identify the statements if each of the students might make to you in their case. Okay. Answer the following problems about what each student needs to know about their line of reflection to support their claim. So, let's see. Let's move really quick. It says to support his claim, the line of is a median. Travis will need to show what? Okay, so you're doing all these four things, and then here it says provided as a flow diagram of statements that can be shown, and then here is a flow diagram. This is what a flow diagram looks. Some people make each of these a box so that you can see what one idea is, and then we'll do that. So it says use 4 different colors. Here's your 4 different colors. And then if you want, you can use these 4 different colors. Just kind of get your best. This is yellow. I don't think we have a yellow. So this is going to be orange. Orange. This is orange, Miss Johnson. Sorry, this one's orange. Green, we have green. Blue, we have blue. And purple, we have purple. We'll make this one purple. Or if you want red. You're going to highlight each of these as to say which color each of them use. So you can just go like this. So I think Travis was orange. I think Tahani was green, right? Yeah, Tahani was green. And then we have blue. And I think that color is closer to purple, so I'm going to use purple. But purple kind of looks like blue, so I'm going to go with red. Sorry, I lied. Red. Okay, so you're going to highlight or circle each of these statements in one of the colors, telling me who would use this to prove their case. Who would use this to prove their case? Each of these statements, like say you thought that Travis needed this one, then you would put this in orange. Does that make sense? All right, so I'm going to let you guys work just a little bit. Okay, so I'm just going to tell you that everyone needed to say that it was an equilateral triangle. Everyone needed to say this, okay? So this is everybody. So I'm going to put a red dot. I'm going to put a blue dot. I'm going to put a orange dot and a green dot. Because it's given. Everybody needs to start with a given. Now over here, let me see if I got this right. Who said it was an altitude? Let me get these colors right. Median is orange. So median is orange. So therefore it's right. So Carlos needed this, or Travis needed this for sure, right? And then over here we have angle bisector is green. So we're going to go with green for angle bisector. Does everybody see this? You would need this one. So blue is altitude. So therefore blue is altitude. And therefore red is going to be perpendicular bisector. Okay. So what I want to say is when we're doing this example here, we're going to decide, do we need these statements to prove that it's an altitude or a median or an angle bisector? So this is where we're going to pick up next time that we get together. But what I really want you all to do is just look. Once I have that it's an equilateral triangle, I know that AB is congruent to BC, congruent to AC. And then who would need this? Who would need that it's a line of reflection? Okay. And then who would need this part, that it's perpendicular? Hint, hint. Who would need that it's perpendicular? Wait, you guys just tell me right now. Who needs to prove something perpendicular of altitude, median, angle bisector, and perpendicular bisector? Which one of these guys would need to prove that it's perpendicular? Yes, for sure, whoever's doing the perpendicular bisector. Yes, very good. So I'm going to put a little red dot right here. Very good. And the altitude, right? And blue, whoever blue is. Very good. So because I need something perpendicular, it's going to have to be this. Who needs the midpoint? who needs to prove that this is a midpoint? And that's what I want you to do. And some of you are going to be like, oh, of course he needs that kind of thing. So this is where we're going to pause really quick, and then we will continue on the next video.